Hi there, welcome to this calculus tutorial. Today we're going to talk about finding the area bounded between two curves, like in the problem shown. It says determine the area bounded by x equals 1/2 y squared minus 3 and y equals x minus 1. So the first step is to find the points of intersection. So in order to do that, we need them both to be in the same form. So meaning they both either need to be x equals something, or they both need to be in the form of y equals something. So right now we have one that starts out x equals and then something in terms of y, and the other one is y equals. So we need to change one of them. Well, the easiest one to change looks like this second one. So if I were to rewrite this, I add 1 to both sides, I get y plus 1 equals x. Or if I rewrite that, x equals y plus 1. So now it's in the same form as the first equation, and I can set them equal to each other. So 1/2 y squared minus 3 equals y plus 1. And now let's go ahead and rearrange a little bit. When I move things around, I get 1/2 y squared minus y minus 4 equals 0. And I can go ahead and multiply both sides by 2 in order to get rid of that 1/2. So I end up with y squared minus 2y minus 8 equals 0. So now I need to factor. And when I factor this, I end up getting y minus 4 and y plus 2. So my answers or solutions to this problem are 4 and negative 2. So now I need to plug these back in to one of my original two equations. It won't matter which, since these are points of intersection. And I get the xy coordinates. And when I do that, I get 5, 4 and negative 1, negative 2. So these are the 2 points where these two graphs will intersect. So let me go ahead and draw this out. So if I go, let's see, negative 1, negative 2, negative 3, 1, 2, 3, 4, 5, positive 1, 2, 3, 4, and negative 1, 2, 3. So the first one, 5, 4, 1, 2, 3, 4, 5, and up 4. I get a point right there. And then negative 1, negative 2, I get a point right here. So now let me graph each of these functions. So the first one, x equals 1/2 y squared minus 3. That's going to be a sideways parabola. It's going to go back all the way to negative 3, and it's going to curve around like this, crossing through each of those points. So when I do that, I end up getting something like this. Now mind you, these are not drawn exactly to scale, but at least we have an idea of the picture, the general shape. So that's that first one. Let me draw the other one. So I have x equals y plus 1, or we are used to seeing it as y equals x minus 1. So it's going to go through minus 1, and it's going to be a straight line. And when I do this, I don't quite hit through my line. Let me try that one more time. See if I can draw a straight line here. There, that looks better. And then the shaded area is what we're trying to find the area of. It's the area bounded between these two curves. Now, you might have noticed I have some notes over here on the side. So there's two cases when we're finding areas between curves. The first case is when we have an upper and a lower bound. The second case, which is what we have here, is when we have a left and a right bound. And so because I noticed I don't really have an upper and a lower, because if you look right here, it's left and right as opposed to up and down. So left and right is the one that I'm going to want to use. So I want to use this example or this definition of the area between the two curves. So that means I'll have a bound at the top, and in this case, my D is 4, and then I'll have a bound down at the bottom. And in this case, my C is negative 2. So those will be my bounds or my limits of my integral. And now we follow the function as shown. So let me draw in my actual functions. So my right one is the x equals y plus 1, and then the left function is the x equals 1/2 y squared minus 3. And notice it's the right minus the left when we plug this into our area equation. So the area goes from negative 2 up to 4. That's my C and my D. And then I have my right function, so y plus 1, minus my left function, 1/2 y squared minus 3, and then dy, because I'm taking this integral with respect to y. And now let me do a little bit of simplification before I take the integral. I have to first distribute this -1 sign. It's probably the most common thing that people mix up, is they forget to put the parentheses in and then their negative signs don't line up. So when I do this, I have y plus 1 minus 1/2 y squared plus 3. So let me rearrange things. I still have limits from -2 to 4 of -1/2 y squared plus y plus 4 dy. So when I do the actual integration, I end up with -1/6 y cubed plus 1/2 y squared plus 4y from -2 to 4. When I plug those in, I end up getting 40/3 minus -14/3, and that simplifies down to simply 18. And that then is the area bounded between these two curves. So I hope that this helps. When you're doing problems like this, just remember to always follow this same process. First, find the points of intersection. Next, draw a graph along with those points of intersection. Then figure out, is it an upper-lower area or a left and right bounded area? And follow the process as we went through it to get your answer. Good luck!